sample tube is transparent. Alright, and this is good. This is the width. This is the width of the sample. So it also depends, absorbance also depends upon the width of the sample tube. Now, because of which we can say a relation between absorbance, concentration and path length, where A stands for the absorbance, which has no units, C stands for the concentration of the sample inside the sample container, and L stands for the path length. This alpha or some, this is basically molar extension coefficient or molar absorptivity coefficient, and it is generally denoted by epsilon. I could not get that in the symbol in the PPT, so I just inserted alpha beside for that. So this is A equal to alpha LC. Proportion. Why do we put proportionality constant? Because in order to remove this directly proportional sign, we generally use a proportionality constant, and over here this is a molar absorptivity coefficient. Now, in our experiment, what we are going to perform our experiment will depend upon the formula, which is this: A equal to log 10 of I naught upon I, where I naught is the intensity of the incident light, and I1 is intensity of the transmitted light. Perfect. Now, for this, our aim is to quantify the concentration of a colored analyte in solution in place of traditional spectrophotometric or colorimetric equipments. Now, in schools we have some of these equipments, but children usually are not accessible to all these equipments. They are costly, they are expensive, and even these spectrophotometric equipments are also there in colleges, but less number of colleges have this. So, in order to provide an alternative solution to get the colorimetric analysis using color picker app, we have done this thing. Actually, this has been performed in US. And then we have just done with our gold nanoparticle solution. We have just seen how we have prepared the gold nanoparticles using tea leaves. So now that's what we are going to use. So this is a color picker app which you can easily download from the Google Play Store. I have selected Pipette color picker, but there is no such selection. I have not seen any difference. You can find obviously some differences, but I just selected it arbitrarily. So it's not that I have particularly chosen this. I just like the word pipette. It's somewhat related to chemistry. That's why I chose this. So this is the color picker app which we are going to download. This is the first thing we do to perform the chemical analysis. We download this app from the Google Play Store, and then we do what? These are the other materials which are required. Stock solution of gold nanoparticles. This is what we have prepared in the last experiment. Then we require glass cuvettes. Glass cuvettes. Of course, we need a smartphone. We have performed the experiment using Galaxy S6 Edge smartphone, but you can do it with even less high-tech smartphones as well. This will do. But obviously the image quality will vary with the smartphones. Now, then obviously you have to download the color picker app from the App Store or your Google Play Store. And then we use auto pipettes to transfer the solution, and the standard flask are used. Now, what is the procedure? Procedure is, firstly, we prepare a stock solution of gold nanoparticles using tea leaves, which we have already described in our previous experiment. Then we do perform the serial dilutions. Serial dilutions to, we perform the serial dilutions, dilutions which range from 160 ppm to 20 ppm. And this is how we perform. Basically, this is the formula M1V1 equal to M2V2. So this is basically for the concentrated sample, and this is for the diluted sample. Once, if we are going to dilute the solution, dilute 160 ppm of solution, molarity would be 160 ppm. Now, how much volume we require for this concentrated solution, we will get from this equation. So if we need to dilute it half, so this would be 80 ppm, and for in this cuvette we have kept 3 ml of the solution. So this ml is 3 ml. So 80 into 3 divided by 160, you will get your V1 volume. So this is how we have prepared serial dilutions. One is stock solution. Then we have 160 ppm of solution. Then again serial dilution were performed, and 80 ppm, 40 ppm, 20 ppm, all those serial dilutions were performed, and we got these samples. Then the data collection was done. Now this was done using the complementary color theory. What is the complementary color theory? Can you see this diagram? This is not working properly. Colors in here. Okay. So basically this is the complementary color theory from which we see that our whole nanoparticles are usually ruby red in color. That's what we say and that's what we see. But can we, Radhika, just in color also. Okay, this is somewhat, the color is somewhat magenta, right? It's somewhat between magenta and red, rose red. This color is coming, right? So, since the complementary color is green, we are going to see the green intensity values from the color picker app. So, analysis was done using this color picker app, and starting from 160 ppm, we use the color picker application to measure the green color intensity at 3 locations in the sample. And this was done. These are the 3 locations. Firstly, this is the first location. We took the green color intensity value. See, 3 values are coming: R, G, B. R corresponds to the red value, G corresponds to the green value, and B stands for the blue value. So we have taken the green intensity value, and we have chosen 3 locations in this sample. This is 1, this is 2, and this is 3. So out of these 3, this is just for this statistical analysis. It's always good to take the average, because one is definitely not going to give you the correct value. So this is the first.
Can you please maintain silence?
See, this is what we are going to do, and please have some concentration in this experiment. It's a good application. You can perform it in your lab also. Once you are done with this, you can go and perform this in your lab. Okay. So we have 3 intensities, and out of which we have taken the average. From these 3 values, we have taken the average green intensity value only. We are not talking about red and blue. That's because we are talking about the complementary colors. Similarly, this is a blank solution. Blank solution का भी निकाला हम लोगों ने 3 locations लेके, and then the average green intensity values was from these values we calculated the absorbance using this equation. Now how this was calculated, I'll show you the table. Now can you see the concentration? This was a blank, water ले लिया बस, and then these are the serial dilutions जो हमने perform किया था in the beginning. Then these are the 3 green intensities value, and this is the average value. Now when we are taking blank solution, the average value of blank is coming out to be this much. This is considered as the I naught. That is the intensity of the incident light, right? So dividing this value actually, I valued by this would give us I by I naught, and putting that value in this equation, A equal to minus log on this, you can calculate the absorbance value. Now with this absorbance value, you can draw a calibration curve, absorbance versus concentration. As we all know that the graph is linear, so this is what we are going to get. And this is the equation of line, y equal to mx plus c. You must be knowing this equation. Yes, what is m? Y equal to mx plus c and c stands for? Intercept. No, it's okay. So it's intercept. Now, so this is how we calculate absorbance and from the average green intensity, and then we prepare the calibration curve by plotting the absorbance versus concentration of each solution and blank. Then from the graph we determine the slope of the best fit, and then we put this value into y equal to mx plus c. Even this graph is drawn using Google Sheets, Google spreadsheets, or even Excel sheets was used for this. And once you draw this graph, this equation will automatically come inside that. So using this equation, you just have to put the value of y, that would be the absorbance, and then you can calculate the calculate the concentration of an unknown sample. So we did that also. For the determination of concentration of unknown sample, again the calibration curve was used. So from that calibration curve, what we did was we first took the unknown sample in the cuvette. Again, this has to be 3 ml, and then इसमें वो नहीं आ रहा.
कितनी देर में बचा है?
Okay, again we are going to take 3 locations, and we from the 3 locations we are going to calculate. We can measure the intensity using the Google color picker app. And from that 3 values, we can again get the average value.
How are you calculating that intensity? Like उसके सामने इसको pick
This is what we are, okay, she'll show you.
And this is the color picker app. We'll
Right.
click on it. We'll have the sample in our qubit.
Right, and then you
And then
We
there
place
is a
it.
camera is
in
here.
front of camera.
We
Okay.
require a white background for it. So we'll
Okay.
place against a white background and we'll just click a photograph of it.
Fine.
And then we'll pick up.
And we make sure that the distance between the qubit and the camera phone must be constant for all the samples. Then only we can get the correct value. So this was done. So again, this color picker application was used and average green intensity was calculated, and further from this green intensity absorbance was calculated. So we get the value of y. Now this y value can be put into the equation, which is in the line equation, and then from that equation we can get the value of x, which is the concentration of an unknown sample. So this is basically the calculation part. You can just go through this. Average intensity के लिए green की intensity plus G2 plus G3 divided by 3, you'll get this value. And for the absorbance value, you just have to this is the intensity, green intensity of the plant. This is the green intensity, so you just have to divide it. You get the absorbance. Now then, from this absorbance, you just put this absorbance value into this equation, which has been obtained from the calibration curve, and then you can just find out the concentration, which is approximately 66.81 ppm. So this paper has been published in 2003 in Journal of Chemical Education. One such paper is also published in our lab, but then the work is different. We have synthesized gold nanoparticles. They have used other absorbing analytes. They have done the analysis of blue food dye and sports drink. Gatorade होता है ना, Gatorade का powder लेके उन्होंने they have performed this experiment. So this is all. So what are the advantages behind the traditional of this experiment behind the traditional over the traditional equipment? Firstly, the data demonstrated that this method is suitably quantitative for an instructive lab exercise using Beer's law to calculate the concentrations from calorimetric data. The above experiment posed no safety hazards. कोई ज़रूरत नहीं है. You can do it anywhere. So you just have to have that qubit and smartphone and your gold solution. Gold solution or even any other solution. You can do it with Chemonoco, you can do it with potassium dichromate or other solution, all colored solution, you can use that. And this obviously provides a feasible lab experience with limited budget. And this approach provides a facile method for performing colorimetric analysis in wide range of settings, even from high school to college to research laboratory. Thank you so much.
Very good.
ईशा
With us. This we come towards the end of the one-day workshop on green chemistry. I thank all the teachers and the students present. And the certificates, the students can claim their certificates from room number 15. Within 1 or 2 days, certificates will be provided. Thank you.
तो नहीं बचाना भाई